In this video, I will be talking about what fractal geometry is and what fractal dimension is. Now, first of all, what is fractal geometry? Fractal geometry is a set of geometric patterns that go on forever. For example, the Sierpinski's triangle. First, we have a triangle, and then we put an upside-down triangle in the middle. Now, we have to do the same thing to these three to continue the pattern. Once we do that, we have another set of three on each side. And so we have to do the same thing, and so on. This pattern goes on forever, and this is considered fractal geometry. Now, the term fractal derives from the fact that fractal geometry has a fractional dimension. So fractal dimension comes in this case. Now, fractal dimension is pretty complicated. To start off simple, we start off with a dimension of 1, and this line has a length of 1 when it is scaled by 1. When we scale it by 2, the length becomes 2. Now, a two-dimensional figure, a square let's say, would have a side length of 1. When you scale it by 2, the side length becomes 2. Now, we move on to a three-dimensional figure. This has a side length of 1, the cube, and then we scale it by 2 again, and the side length becomes 2. Now, we're trying to find the length here, the area here, and the volume here. So we can find a pattern here when we say length is equal to, here we're going to use 1 and 2. These are the scales, and this is going to be 1 to the power 1, 2 to the power 1. Now here it's going to be again 1, 2. Because we scale this by 1 and we scale this by 2, and this is going to have a power of 2 to find the area. And then when we're finding volume here, it's going to be we scaled it by 1 here, and then we scaled it by 2 here, and so we're going to cube these to find the volume. Now, if you look at this, this is a three-dimensional figure, and the exponents here are 3. And then the area here, the exponents are 2, and this is a two-dimensional figure. And then here, this is a one-dimensional group, and the exponents are 1. So we're going to say dimension. This is a 1, a 2, and a 3. So, we can create a formula saying that area, volume, or length, whichever, is equal to the scale that you're scaling it by, so we used 1 and 2 in each of these, to the power dimension. Now, to try this out on fractal geometry, we're going to go to the Sierpinski's triangle, and what we're going to do here is we're going to triple this to make the side length 2, because this is going to have a side length of 1. So we're going to replicate this as shown. So this one, and this one is going to be a replication of this. So So each of these are going to have a side length of 1, and so in total each side is going to have a side length of 2. Now once we did that, we're going to consider the area 3 because we had 3 triangles here. This part is left blank, so we're going to say the area is equal to 3. So 3 is equal to, we scaled it by 2, to the dimension. We're trying to find the dimension of this one. So in this case, we're going to say dimension is equal to, where logarithm comes in, log 2, 3. Or you can say log 3 over log 2. Now you can directly calculate this on a calculator and you're going to get a rational number. So this is an overall brief description of what fractal dimension is and how you can use it in fractal geometry. Now fractal geometry is everywhere, and to interpret that you can use fractal dimension, and everything has a different dimension to it. And so I hope you learned a lot from this video, and thank you for watching.